Before we get into our next big set of protocols, we need to understand a concept called ports. Now, ports are communications endpoints for our connections to our computer. So, if you know what a port is for a, say, a car port or a port that a ship stops in to unload cargo, then you can sort of use that mindset when we're thinking about computer ports. They're a logical endpoint for data or communications to unload onto our computer. Ports are commonly shown as, if we're writing out a port, we have our IP address, so we'll put 192.168.1.13, and then we'll have a colon, and then a port number, so we can have port 80. That's what a port number looks like, colon 80. So why do we have port numbers? Why do we tack those onto the end of our IP addresses? Well, a port number essentially allows us to have multiple applications and multiple different programs and multiple different protocols connecting to our computer at once. If we just had our one IP address with one port and we were receiving multiple different data connections at once, it would be harder for our computer to logically be able to say, okay, this is this protocol, this goes here, and separate all those out into different programs and applications. So we need to have multiple different endpoints for all of our ports to be able to connect, for all of our data streams to be able to connect to. So that's why we have multiple ports. It allows us to have multiple applications and multiple data streams going over one network connection, so we don't have to have 6,500 wires going into the back of our computer. And there are, speaking of 6,500, there are 65,535 ports available per connection. Now, a lot of those ports have protocols which are associated by default with certain ports. For example, port 80 is by default HTTP. And HTTP is how we transmit web page information. So if you load a web page, if you go online, type in google.com and it brings up Google, that data is being transmitted by default to your port 80. So you're sending a data packet out of your port 80, and then when your data is coming back in, it's going to 192.168.1.13 port 80. So because port 80 is the default port for HTTP, that's where it's going to go unless we otherwise specify. Now these defaults can be changed. If you set up a IP camera in your home, you may have a web login page for that IP camera that is not port 80. But if you were to go to HTTP and then the IP address of your IP camera, it wouldn't load the page. And you say, well, why? Why isn't it not loading the page? This is the right address. Well, for security reasons, for security by obscurity, they may have changed that default port and said, okay, this IP camera, its web interface is only able to be reached on 192.168.1.13 port 8033. So that's within our 65,000 port number range. So in order to navigate to that interface for that IP camera, you would have to go to HTTP and colon / 192.168.1.13 port 8083. If you didn't include that, if you didn't include your port 8033, your browser would go, oh, this is an HTTP connection. My default port for HTTP is port 80. So I'm going to tack on port 80, and I'm going to try to communicate with port 80 with this device. And then when it gets to that device, when it gets to this IP address and it tries to initiate a connection with port 80, it's denied. It's blocked. That port 80 is closed. And it says, whoa, wait a second. I'm supposed to be delivering a package here. I guess this is offline. I guess I can't deliver anything here. I guess there's no web interface. But that default port has been changed instead to port 8033. So we need to know that. We also need to know that just changing port numbers isn't a catch-all security measure. We can't just change the different ports for our different protocols and say, oh, okay, I don't need to have secure file transfer protocol. I don't need to have FTPS. I don't need to have file transfer protocol secure. I can just transfer over standard FTP, standard file transfer protocol, or I can just transfer over trivial FTP, TFTP protocol, unencrypted file transfer protocol, and it's okay because I'm just going to change to the default port. Well, that might be all great and jolly for all of about 5 minutes until someone with a port scanner just says, I know they're transmitting files, because this is business. I know this server is an FTP server, but I'm not seeing the standard FTP port open. So let me just set up my port scanner, and I'm just going to have it try to contact every port from 1 to 535. And then when it hits whatever port you set up as your default, as you change to your TFTP port, it's going to say, oh, there it is. And then it's going to start viewing that information, viewing that data. So we need to understand that the defaults can be changed. It can be changed as an additional layer of security for security by obscurity, but it should not ever be our only layer of security. We don't protect our confidential files by creating 100 directories and making a maze with our file folders in order to hide our files and make them secure. That's not how that works. We can use a search and then find where the file is in those folders. We don't hide our Wi-Fi pass. We don't protect our wireless by taking our Wi-Fi and simply disabling SSID broadcast. People can find that and then they can just connect to our wireless. We need to have our files encrypted, and we need to have our wireless set with a WPA2 password. Same thing with our ports. We don't just protect our protocols and we don't protect our servers just by changing the default port numbers for the different protocols we're running. So all of the communications and all of the different protocols which have endpoints that are ports are going to be communicating over either TCP or UDP. All of our different protocols which are communicating to ports need to have some sort of communication protocol to deliver that data. We talked about some of our other protocols which don't work with ports, but these protocols have data packets to deliver. They need to have a logical place. Think of them as ships. They need to have a logical place to stop at our country, at our IP address, and they need to have a place that they can unload the packets. And they need to have some sort of shipping company. They need to have some sort of communications protocol, either TCP or UDP, to determine how they're going to package that data, how they're going to segment those packets, and if we're going to have a connection-based or connection-less protocol, either TCP or UDP. So we'll be discussing our different protocols. And when we do, we'll be discussing either TCP or UDP, as well as the port number that they're associated with. It's very good to learn default port numbers for popular protocols, because if you're analyzing network data or you're analyzing traffic, you'll see those port numbers popping up. And you'll be able to say, okay, this protocol is trying to go here, this program's trying to access here. Why is this program trying to access here? This program shouldn't be doing that. Or why is this data trying to access here? Or if we see certain sequences of ports being hit on our firewall, we can recognize very quickly, oh, this shouldn't be hitting this port or this port or this port. So it's very important to learn default ports and protocols for popular protocols, so that we have them in our mental toolkit to use and not have to be constantly carrying a chart around. And when you go into a test, they're not going to let you carry a chart into a test. So you need to, the only chart you're going to be able to carry is the one that you've already memorized in your head for which protocols go with which ports. So enough said about that. Lastly, our ports, they're going to be at our transport layer, layer 4. We've mentioned how our ports are related with TCP and UDP. Layer 4 is our transport layer, where our TCP and UDP live, where our TCP and UDP package up our packets, segment our packets up, and begin to set up communications with other endpoints. And so our ports are also going to be at the transport layer, because it's going to be the transport location where we send packets from and where we receive packets to. So just remember, our ports are communications endpoints. We have 65,535 ports per IP address, ports per connection. Default ports can be changed. Communications are TCP or UDP, transport layer 4, and a port looks like this. 192.168.1.13 is our IP address with colon, meaning port number, whichever port number we have.